Hello and welcome to a new video. This is kind of like a pre-lesson 16 for Precalculus Math UC, because in lesson 16 we basically need to kind of understand where different radian angles are. And so the best way to do that is to pull out our handy dandy unit circle that we filled out some of weeks ago. I don't even know how long ago at this point, and to revisit that and fill in radian angles. If you are going to end up taking a pre-calculus / trigonometry class in college, or even if you go on to calculus, this will be something that you'll want to really pay attention to and memorize at some point. But if you're just doing pre-calculus math UC and then going on to just, I don't know, college algebra or something, maybe not as important to memorize it. Definitely keep an ear out for future math classes on whether or not they expect you to have this memorized or not. So this actually is what we filled in, what I filled in an earlier video, I think, or maybe in class, where I've got the degrees actually on the inside here of the circle. I put the quadrant points. The points aren't going to matter as much for us right now, but if you already have this filled in, then that's fine. What I want to do is go around and fill in the radians. So for instance, 0 degrees is also 0 radians. By the way, this is also 360 degrees and is also 2 pi radians. And then from there, I want to go around the circle filling things in. And I do want to kind of, instead of just like giving it to you to copy, I want to kind of explain why or how you can come up with this on your own. Kind of go through how I figure it out, because I have this memorized, but like, it's not that I concentrate on memorizing the unit circle in and of itself, it's that I understand how radians work, and so that allows me to figure out where these angles are. So for instance, there are 180 degrees in pi radians, or vice versa. So over here at 180 degrees should be pi, and then from there we can use fractions. So up and down, 90 degrees is halfway between 0 and pi. What would be halfway between 0 and pi? Well, what's half a pi? It would be half a pi. So we actually call this pi over 2. Also, because last lesson, lesson 15, we learned how to convert between degrees and radians, you could just convert all of these by multiplying every single one of these by pi over 180. And that would also get you your radians. I would recommend only doing that once and then having the unit circle handy so that you can just use that, because having to do a whole bunch of these over and over again could potentially be frustrating. Where can we go from here? So straight down would be halfway between 1 pi and 2 pi. Well, halfway between 1 pi and 2 pi would be 1.5 pi's, which we'd put as an improper fraction, which is 3 halves, or 3 pi over 2. So kind of, if you can break this down into fractions and ignore the pi, but then remember to put the pi back in, that's probably one of the easier ways to come up with this without actually just converting them. For instance, if we think of straight up and down as a half and our line is 0, then halfway between 0 and a half is a fourth. So 45 degrees is also pi over 4. And by the way, there's also this connection that 45 times 4 is 180. So remember our conversion factor of pi equaling 180. That's a connection there. And that same connection is how we would get the things for 30 and 60. Because 30 degrees, when you convert it, you're having to think, how many times does 30 go into 180? Which is 6 times. So this is pi over 6. If we do that, but with 60 instead of 30, then we get pi over 3. So once we have those, then we fill in the rest of the quadrants. So like, let's count by a fourth pi's. Each of these middle angles has to do with something over 4, which is one of the ways that it's helpful to memorize this. Because we have, in the first quadrant, we have a fourth pi, and then straight up and down would be a half pi, which would be like 2/4. And so then in this quadrant, we have 3/4 pi, so 3 pi over 4. And then this would be 4 pi over 4, which is just pi. And then we'd go 5 pi over 4. We're just counting by fourth pi's. Then we'd have 6 pi over 4. And then we'd have 7 pi over 4. And again, you could just convert these. We could do 315 times pi over 180 and simplify 315 over 180, and we get 7 over 4. But this is kind of another way to do that. The other one that we can do similarly to that is pi over 3, thinking of it as thirds. So we have a third pi. So up here would be 2/3 pi. And in some ways this one actually works better because we get to skip over the middle. And then we'd have 3/3 pi, which is just 1 pi. And then we'd have 4/3 pi. So 4 pi over 3. That's the wrong spot. Don't put it there. Whoa. Where's my eraser? That's not the right spot. The over 3s are all the ones closest to the y-axis. So this is 4 pi over 3. Whew, that was a close one. You might be thinking, no, that was exactly not surprising at all because this is so confusing. I don't know. So 4 pi over 3 is down in the third quadrant, and then 5 pi over 3 would be over here. So each of the, like, there's symmetry here. We've got over 6 over 4 over 3, and then on the other side, over 3 over 4 over 6. So each of these that's closest to the x-axis, those all have reference angles of 30 degrees, so they're all going to be over 6 for our radians. So here it might be easier to just think, what is 1/6 short of 1 pi? Because basically this angle is pi over 6, or 30. So what would it mean to do 1 minus 1/6? And how many pi's would we have? That would be 5/6, so that's 5 pi over 6. This one down here in the third quadrant would be pi over 6 more than pi, because that's this part right here is pi over 6 more than pi. So that would be 7 pi over 6. And then over here in the fourth quadrant, it would be 2 pi minus pi over 6, which would be 11 pi over 6. So as I said, I think the helpfulness here is, okay, you've seen it, you've hopefully written it down. And so now what you can do is use this as you're doing your homework. So you even could go back to lesson 15 now if you've already done it, but look at it and say, like, I don't necessarily think it's helpful for you to look at this instead of converting them. I think that was a helpful exercise to do to start off with. But if we wanted to try to figure out some other things using radians, I would say, hey, see if using this helps you. And especially if you do have the points filled in, then all of a sudden if we ask ourselves, hey, what's cosine of 11 pi over 6? Well, the way we do that with the unit circle is we say, where's 11 pi over 6? And cosine is the x value, so that would be square root of 3 over 2. So cosine of 11 pi over 6 is square root of 3 over 2. So we've also just opened ourselves to be able to answer like twice as many questions with our unit circle. But this will also help you with lesson 16 of Precalculus Math UC, or maybe you're just, trying to memorize radians on a unit circle. Hopefully this helped with that. So thanks for watching. Bye.